So consider the region enclosed by the graph of y equals 4. Let's just kind of do a real rough sketch of what we know. If y equals 4, that's basically the horizontal line. We got the line y equals e to the x, which, remember, when e to the 0 is 1, so I know that I'm going to go through here and then it's going to exponentially grow. And the equation, or the y-axis. So I've got this region right here. The line k, x equals k, will be used to cut that region into 2 equal areas. So let's think about that. I have a line at x equals k. Well, x equals is going a vertical line, and it has to go, so it's going to cut that region equally into 2. Now, what we don't know is where that's going to be, but we know we can call it x equals k. So what I need to do is I need to say, well, the area right here on the left has to be equal to the area on the right. Well, let's just look at what is the area on the left. It's the area between the top bound and the lower bound from where to where? Where does it start? It starts at x equals 0, and it goes until x equals k. So I'm going to set up an integral that's going to represent the left area from 0 to k, and then I have to do the top bound. Well, the top function is 4, the bottom function is e to the x. So if I set this up, I know the region from 0 to k is the top function minus the bottom function with respect to x. And that's my left area. And that left area has to equal the area on the right. Well, the area on the right, where does it start? Right here at k, and where does it end? It ends at, I'm going to be careful here, so what value would this be? It's when 4 is equal to e to the x. So then you have to solve for that by moving the e over to the other side of the natural log. And that's where this line would be, at the ln of 4. And then what is its top function? Its top function is 4 minus the bottom function of e to the x dx. And which option is that? Is it this one? So notice we're thinking a little abstractly or generalizing it, but the big idea is area under the curve. And k is the line that makes the left side equal to the right side. So this could be a very intimidating problem. It probably was, right? And now that we see it and break it down, there are questions like this on the AP test where if you think of the conceptual side, meaning if you see something that has an integral, waiting for my highlighter to fall. There we go. If you see something like this, that's in all your answers, what does that mean? It's the area under the curve from 0 to k. We're thinking of integrals area under the curve. And same thing here. So if you can try to visualize it, a lot of times a quick sketch makes this problem so much easier. Okay. I wanted to show you this. This is something that you would have to be motivated, and I really hope you take advantage of this opportunity. There are AP live videos starting today that review Unit 1 through Unit 8, and that's going to go over kind of the big main concept. It's not going to give you every single thing you need, but I really hope you take advantage of it. So there are 2 ways to view this. You can go to the YouTube channel, which if you use this site, if you just subscribe to Advanced Placement, you'd have to spell it correctly. There we go. But let me just show you what that site looks like quickly and where to find it. So once you go to Advanced Placement, you'll get right here, and then you have to scroll down until you see
And this would be true for any video, by the way. If you have other AP classes, look at the titles and kind of follow what you need. But here's the AP Calc AB. And when you click on this, now notice it says live starting today. It's going to be posted at 6 p.m. it looks like. So if you want to wait a day and then always be a day behind, you can watch them all at once if you want, but they're usually 12 to 15 minute videos that cover major concepts from Unit 1, Unit 2, Unit 3, and so on. And they kind of have the titles here for each session. So like understanding derivatives and chain rule. That's a real big one. Contextual and analytical, what was this? Analytical applications with a derivative. How to find limits and continuity. Okay? A lot of that is from Unit 1 and Unit 2. And then they get into integrals, understanding the big theorems like the mean value theorem, intermediate value theorem, and extreme value theorem. Applications. And they're going to review for, I think, the next 2 weeks. So you got a bunch of videos there that you can take advantage of. If you can't find them on YouTube, if you visit the AP Central site, it'll have the same information there for you to view. Yes?
Is it possible if you could put on, like, tests on school feeders for us to, like, reading problems?
Like practice AP tests?
Yeah.
That's where AP Central comes in, and I think, I don't know if I have that up here, but yes, but it would be through AP Central. So we'll show you that here. I want to show you this as well. It's a site that just might help build some confidence in where we're at. Don't worry about this site. It's not that important for you guys to go on your own unless you want to play around with it. It's called appass.com. And we're looking at the AP AB calculus score like calculator. So how would I earn a 5? Obviously, if you got everything right, the 45 questions on multiple choice and the 6 9-point free response questions. So if you got 100%, you get a 5, no problem, right? And this is from 2017. So this is not super recent, but it just kind of gives you an idea of what scores you can get. Now, let's have some fun with this. What if I got, let's go 20 out of 45. So I had about 45%, 44% accuracy on the multiple choice. And then I got 4s on all the AP, all the free response questions. Now some free response questions, you might get a 0, and others you might get a 9. But let's just add average and 4. So right now, what do you think my AP projected score would be? 2. Think it's a 2? It's a 3. That's college credit. Now look at the percentage, if you can see it. Well, actually there's not a percentage there, but it's 48 out of 108. Let's think of that just as what percentage of accuracy. That's a 44%, and you can still earn college credit. Now what if I drop down a little bit? What if we say 18? I recalculate. That's still a 3. Let's say 17. That's still a 3. 16. 15. We're still at a 3. Okay? 13. We're still at a 3.
Okay, what is a 2 now?
Okay, that's where we're, okay, there, now we're at a 2, right? So, do you feel a little better? Okay, and that's the idea. If we were in a normal year, we would have taken one practice test already, which we're going to be doing soon. But that's the thing that you guys just need to see. You do not have to be perfect. In fact, like at 80%, let's see if I can get this to calculate some other scores. A 4 here is 61 out of 108 points. And we could play around a little bit, but it just gives you an idea of the range of how many you can get wrong. There's a large margin of error, and they know that they're testing on every concept that we've learned. Some you've mastered, to be honest, some you'll have no clue with. And it's okay to skip a couple questions here and there because you don't want to waste time on the hard, difficult problems that you might not get anyways. So I hope that just kind of gave you a little bit of confidence as we start to review. All right. I also want to show you this. The AP exam for anybody who's taking it digitally. There are 3 people that are listed as taking this at home. I'm going to email you guys this information, but you will need a lockdown browser to take this at home. And if you have a school Chromebook, we're working on getting that updated so it's automatically going to be on your Chromebook. But I will send this information out. Most of us are taking it at home, so I'm going to send this link to you guys later on. But there is digital practice, so kind of answer your question. There is a digital practice for those who are taking the exam at home, and it's just to kind of see, does the lockdown browser work? Do you know how they're going to answer those questions? And this is just a ton of information. We're not going to go through that in detail right now. But I do want to show you that AP Central site. Let's see if this pops up. There we go. This is not working. I'll get that set up later on in the week and show you how we can access those. Maybe we can do that this afternoon too. Okay, so we've got our last day of revolving solids and doing volume, but now we're going to be parallel to an X or a Y axis. So we're still taking that same idea. We could have a washer, we could have a disc, but now instead of being directly revolved around an X or a Y axis, it could be a line parallel to that. So the only difference is how we interpret the radius. Otherwise, the same work is true that we did the last week and a half. All right, so we're going to start with this one. My computer at home is different size screen than this one. But our goal is to find the volume of the solid of a solid revolution by revolving around the line y equals -1. So think about where that's going to be. Y equals -1 is a horizontal line. It's parallel to the x-axis. But we're going to approach this the same way we did before. Here are my 3 functions that are going to create the region that we're going to revolve around. So what I would do is let's create a rough sketch of a graph that's contained between y equals 1, x equals 0, and y equals -x plus 4. So I've got the line y equals 1. And then I've got the line x equals 0. Then we've got the linear equation, -x plus 4. So with this one, I'm going to think, well, I've got a y-intercept at 4. 1, 2, 3, 4. And then I have to go down 1 over 1 as a slope. And you don't have to go super crazy. You just need to get that region bound between those values.
here's the spot you have to be very careful with. Is they're asking us to rotate about the line y equals -1. So I always draw a dotted line, and then I either do a little arrow like that. Sometimes I'll even write the word rotate, so I don't forget where I'm focused on. Because a lot of times you can kind of revert back to what you've been doing and just rotate around about the wrong axis. So if I'm going to rotate about the line y equals -1, I need to take this image and reflect it completely over. So let's think of this. From the dotted line, I went up 2 units to get to my first spot. I'm going to go down 2, put a dot, and then I'm going to follow that over as well. And then I want to think, well, how far is this point away from where we started? And that was 1, 2, 3 units. So I got to go 1, 2, 3 units below. That will help me create that triangle for the, so we can rotate. Is this going to be a washer or a desk? Let's pick a random point. And if I rotate around here, we've got the intersection point. We do have that washer. Now, as always, the challenge is finding the radii. What is the radii of each one? And it's the large radius minus the small radius. Let's think of that large radius first. We have to think of where is the center of our washer. Where does the center of the washer start? Y equals 1. It starts right here, and then I'm going to go up until I hit this line. Now let's think about that. This is a tricky spot. How far is it from the dotted line to the x-axis? It's 1, right? And then how far is it from the y-axis up to this equation? That's where we have to use the equation itself. So this is where, let's see if I can get a better color. This distance right here in orange is the equation -x plus 4. And then this equation from here to here is 1. So to find the full radius, it's the sum of those two added together. So it's 1 plus -x plus 4. Make that one a little darker.
I don't know if it's smaller radius. Does it go to the axis or does it go to the triangle?
Yeah, so then we're going to look at the smaller one here. The smaller radius still starts at the same center spot, and then we got to go up to this curve right here. Well, no matter where I'm at, how long is that? It's technically, this distance here is 1, plus the distance from the x-axis up to the function is 1, and it's always 1. So an easy thing to say is it's 2, but why is it 2? It's because we're 1 unit away from the x-axis plus the function itself. Because if this wasn't a straight line, then it would be the function itself instead of the number 1. That's the hardest part, and really that's technically the only new part. Because what is the area then? Area of any washer is the large radius squared minus the small radius squared times pi. You just have to make sure you use grouping symbols when you do that. And actually, I should probably simplify the large radius here. We can call that negative x plus 5 instead. With 1 plus 4 sine. Alright, so you could do as much simplifying as you want within the idea of this area, but just a quick reminder, what is volume? Volume is the accumulation of the area and then since we're rotating parallel to the x-axis, all my values are stacked up in terms of x, so we're going to have dx here. And then it's just the same work we did last week. Now we are going to do this one by hand. And I'm going to end up simplifying as well. Don't forget I is that constant that can float to the outside. What are the bounds here? We're stacking up across the x-axis. So where's my first bound start? At x equals 0. And where does it end? We got to kind of count it out. 1, 1, 2, 3. So see how this intersection point right here is at the spot 1, 3. Oh, sorry, 3, 1. Sorry, go there wrong. This is the x-axis. 1 over 3 up 1. So we're stacking from 0 all the way to 3. And now, I want to do this without a calculator. We did a lot with the calculator the other day. And there's some of this that you could do in your head. Or if you're not confident, do the side work. But I have to first square or FOIL out this part. So I got to think of what does it mean to be squared. FOIL, distribute, whatever you need to do. If you want to use the box method, you can. But I get x times negative x, which is a positive x squared. And then I get a negative x times 5. And then a 5 times negative x. And a 25. And then you can do that. If you can do all this in your head, you don't need to show any of that work. That's just side work. Right? But that's what this red portion is going to turn into. And then we could actually combine the 25 minus the 4. And again, if you see that right away, save yourself work. You don't get any extra points for showing more work here.
And now it's time to do the antiderivative. So hopefully you're super confident right now. I'll let you guys do it, I'll do it. Let's just compare our answers here. So we should get 27 pi at the end. If this was a free response question, you would earn full credit if you stopped. Wait, my highlighter pop up. If you stopped right here, and your parentheses were all accurate, you would earn full credit. You would not earn full credit if you stopped here. Okay? Part of evaluating the integral is plugging in the upper bound minus the lower bound. So you have to evaluate, but you don't get any extra for doing the algebra piece, the simple part. That's a time-saving technique, right? Or if this is a no calculator problem and you think you're going to make a mistake here, stop.
You could stop at the.
No, you cannot stop here because part of the act of doing the integral is evaluating it at the upper minus the lower bound, and we didn't do that until we got to this highlighted step. So, okay, let's look at this one. What happens now instead of revolving around a line parallel to the x-axis? What if I revolve around a line that is parallel to the y-axis? So you don't have to write all this. Let's just sketch a graph, but our goal is to find the volume of the solid generated by revolving the region bounded by the parabola y equals the square root of x. So if you're sketching your graph, we'll just label the red one as y equals square root of x. And the line y equals 2. Blue one, and x equals 0, which is the x-axis. Then our job is to rotate about the line x equals 4. This was actually the one that we had last Wednesday. It was part D that we never got to. So
once you have the graph sketched, flip it over that red dotted line and see if you can draw the side that's over on the right-hand side now. This graph is going to be gigantic. But I know that this point right here is 4 units away from where I'm rotating. So I'll have another point 4 units past that at 8. And then I know I'll go over 8 up 2, and that will give me this point here. And then the other intersection point lies on the rotation. So it should look like that. Definitely not drawn to scale nor accurate, but it doesn't matter. If I rotate it and I pick a random point, let's pick a random point and then fill in all the spots where if I reflect it, we would get that. Doesn't matter, right? Because our job is just to kind of visualize what shape or what type of cross section is present here. You can see it's that washer. And then challenge is what is the large radius and what is the small radius. Now here's my hint for finding the radii. We really want to focus kind of on the functions themselves. So in this case, start at let's look at the big radius first. The large radius goes from the center of rotation all the way out until we hit that x-axis. And it doesn't matter where I am at, which point I pick, right? I could pick any random point, but what is that big radius always going to be? 4, right? How long is it? It's 4 units. So, my large radius is 4. That's the easy one. Because you can literally just count, and that radius never changes. But what about the radius in the small circle? So from here to here. Now we have to be very careful with this. Because I can't count here, because if I was to pick a different point, notice that small radius changes. It's changing, and how is it changing? It's changing based off of the behavior of this function. In years past, this is a spot where I felt like some kids kind of lost what we were thinking. Here's what we know. This is the x-axis, or the y-axis right here. The distance from the y-axis to the curve itself is the equation. So this purple line that I just drew is the equation, but it's the equation written in terms of y. So y has to be in the equation. So the purple length right here is really y squared. But I don't want the purple length, I want the blue length. So how long is the blue length? How can we find that? 4 minus y squared, right? Because the whole thing is 4. The purple part is y squared, so the blue is what's left over. It's the 4 minus y squared. If you feel confident in that, you got it, because that's the only new part today. Okay. Well, let's think of that again. What did we do? I knew that the full length from here to here is 4. That's the red line. I know that the purple length is the equation y squared, but I don't want that part. I want the part that's the small circle of the washer, small radius of the washer. So it's the blue piece, which is the 4 minus the y squared. Alright, so then, and this is the part that if you've done enough of these, you can skip right in the area formula and put it right into the integral. You don't get any points for doing the area. I just do that because that's really what we're doing, is we're accumulating the area. And then you have to be very careful with your squares. Right? It's the big radius squared minus whatever the small radius squared is. And then volume is the integration of the area. And here's where you could skip some steps. 4 squared is 16. If you are comfortable, could you FOIL this out in your head? If you can, go ahead and do it. I know I'll have 4 times 4, which is 16. I'll have 4 times negative y squared, but then it'll be doubled. So I'll get a negative 8y squared. And then I'll have negative y squared squared, which is a positive y to the 4th. If you don't like that, then do this part as side work and just FOIL it out on your own. Don't try to do too much in your head if you know that you might make an error. What's going to go right here? dy. Okay. Why do we know it's dy? A couple of reasons. The radius is written in terms of y. My bounds are stacking up from bottom to top. So what is the lower bound here? 0. What's the highest bound? 2. The largest circle would be here at y equals 0. And then we're going up to y equals 2. So we're stacking vertically, which means we're doing everything in terms of y. The other thing you have to be careful with, that negative being distributed. Now, if you know that this 16 and the minus 16 are going to reduce out, you don't have to write that. So it can really just be 8 squared minus y to the 4th dy. Save some steps. So get a negative 16, 16 minus 16 is 0. Negative 8 y squared turns into a positive. And now, why don't you guys go ahead and do the antiderivative and see if you get the same answer that, I actually had this from the other day, so I have the answer already written. You should get this as an answer. So I took the antiderivatives. First thing, if I was grading this, what I usually check is I check to see did you set things up correctly. And then I check your antiderivatives. So did you get 8/3 y to the 3rd minus 1/5 y to the 5th, evaluated from 2 to 0. And then I plug in 2. And technically I don't have to write. If I plug in 0, it's going to be 0 anyways. So So I didn't write that all out. And then 2 cubed is 8. 8 times 8 is 64 divided by 3. 2 squared is, or 2 to the 5th power is 32 times 1 divided by 5. And then at this point, if I really had to do all this by hand, I would times this by 5, and this by 5, and this by 3, and this by 3. At this point, I just grab my calculator. Did you guys get 224 over 15? And then you could stop here again. Now, here's the benefit, right? You would get full credit if you stopped there. That would save you a ton of time trying to do all that by your hand. Don't waste the time trying to get to this answer of 224 pi over 15. So, I understand these problems are not super easy. They're challenging. So I'm only giving you 4 problems tonight for homework. The answers are completely worked out. They're in Schoology. I would like you to try all of these by hand. And that means you're probably going to have to FOIL some items out. But that's why I also only gave 4, is so you can work on the by hand piece. And like the last example, if you got to a point where there's really big numbers, you can just multiply fractions together, but try to do it as far as you can all the way to the final answer without a calculator. And then either use your calculator to check or check your answers online. Before you guys on Zoom, before you leave on Zoom, I want to show you one thing that I'm going to do that'll help you guys review if needed. Oh, yep. Well, so let's, if this was a no calculator question, then you can possibly do it. If it was a calculator question, then all I would do is set up this. You don't have to show any work, because it's just, oh, you can use a calculator? Cool. Plug in, you don't show in. The one thing you can careful here, so you set up the notation, the integral symbol's gone, and the line should be behind it. This, if I'm reading it, this tells me you're using a negative. That's what that integral symbol means. So notation-wise, once you take the antiderivative, that integral symbol is gone. Yep. So notice right here. I have it written here. This symbol right here, the integral symbol here, tells me to take the antiderivative, and notice how it's gone, and then the dy is gone, and it turns into bounds. That's evaluating from 2 to 0. So that's a big notation thing. Okay, here's what I'm doing. I actually got it to work, and there's a question about options for practicing AP. So everybody give us a quick little look. What I'm doing is I'm going to our progress checks, and we didn't do these a lot because I wanted to save them for the review. So what I'm going to do is I'm going to open up every single progress check, and let's see if I just go to home. At the end of each unit, so if I go to unit 1, you guys have access to this too. You could watch daily videos if you want. Those have been there all year. Then if you scroll down to the bottom, there are personal progress checks that are multiple choice and free responses. So when you answer those, you'll get feedback on them, and you can grade the free response questions yourself. Now, I'm not saying you have to do these. This is completely optional. But if you want to start reviewing, and maybe it's unit 1 on limits and continuity, maybe you're really not confident on that. If you go to unit 2, and you're more confident in the definition of the derivative or the application of composite, implicit, and inverse functions, you can pick which ones you want to choose to do.
So those are options for you. I'm going to actually, it might take a while, but I'm going to release all of those so you can do them at your own pace. And keep in mind, there are some questions that are going to seem impossible, and that's okay. We saw that the AP, you're allowed to miss a significant amount of questions and still earn a 5. So don't spend too much time on any of them, and give it your best shot. All right, so that's what I got here. I have not got confirmation yet. I'm just curious. I think on Wednesday I'll do a poll, but here's what I'm thinking. Friday, May 14th, I'm thinking about providing an opportunity where you guys come into Tartan and take a real full AP exam, multiple choice and free response. It would take about 4 hours. And then we will use those results and I'll grade the free response. I have to get approval from Miss Thompson if we can do that. But if we can do that, that might be a great opportunity for you guys to come in on a Friday and get some work done and really get some extra practice. So I'll let you know once I get confirmation. If that doesn't work, then what I'm going to do is have practice take-home tests, and you would just have to follow the structure, and you could do that as well. So, but that's the plan, is we're going to have a lot of opportunities for you to review over the next month and change. What's that, Ashley?
Could distance learning students also come in then?
That's what I'm asking for. So again, I have to get approval, but the thought would be any student in my class, distance or hybrid, I'm curious if you guys can come in on a Friday, and since there aren't students in the building on Friday, I think that limits the risk of having people come in. But there's a lot of logical or logistical steps that have to be cleared and approved before I can officially say that, yes, we're going to do this. So I'll keep you posted. But I think that would be a great opportunity